compound on for this work, so he knows exactly which area of the bearing has to be scraped. He only wants to scrape the high spots. Any low spots have to be left at this point. What he's trying to do is get a completely flat bearing surface so that this shoe will mate properly with the thrust collar. He continues scraping until all the blue dye compound has been removed. Then this shoe is cleaned and the contact check is repeated until complete contact is made by all the shoes in the thrust bearing. With that, we've seen how to check the shoes of a tilting pad oil film thrust bearing for proper contact with the collar. Before the bearing can be reassembled and placed back on the pump, it has to be completely cleaned. While the worker finishes his cleanup work, why don't you discuss contact checking with your instructor? When you come back, we'll see how the bearing is put back together and placed back on the shaft of the pump. Before the break, the worker checked the contact between the thrust collar and the shoes of the thrust bearing. He's just finished cleaning the bearing parts, and he's begun putting the bearing back together. Let's join him. Before placing the bearing shoes back on the retainer ring, the worker applies a small amount of oil to protect the surfaces of the bearing retainer ring and the bearing shoes. Now he can place the set of shoes back on its retainer. He matches the numbers on the shoes with the corresponding numbers that he scribed on the retainer ring. The worker makes sure each shoe is put back in its original position. When doing this work, it's important that he only works on one set of shoes at a time. He doesn't want to accidentally switch retainer rings, to assemble the wrong shoes on a retainer ring. If he did this, he might have problems with alignment of the bearing when he placed the bearing assembly back on the shaft. He continues placing shoes on the retainer rings until all of them are in the proper position. The bearing assembly is clamped back together to prepare for placing it back on the shaft. The cover is removed from the bearing housing. To prepare for putting the thrust collar assembly back on the shaft, the shims are placed back in their position and the key is placed back in the keyway in the shaft. Then he's ready to install the thrust bearing assembly back on the shaft. To do this, he merely slides it into position, but there are a few things to look out for. Remember, this assembly has a keyway in it, so when the collar is slid onto the shaft, the keyway must be aligned with the key. What the worker did in this case to help him line up everything was to align the parallel clamp with the keyway when he put the bearing assembly back together. This gives him an easy method of assuring proper alignment of the keyway and key as he slides the bearing assembly back on the shaft. At this point, the thrust collar is in its proper final position. Once the thrust collar is up against the shims and shaft shoulder, the next step is to reinstall the retainer nut. So he threads the retainer back onto the shaft. As he does this, he's very careful to check to make sure that he doesn't cross any threads, and he continues threading the retainer until it stops against the thrust collar. Once it's in position, he takes a spanner wrench and makes a final tightening. Next, he reinstalls the retainer set screws. Again, as he does this, he's very careful not to cross any threads, and he uses a hex key wrench for the final tightening, being very careful not to over-tighten, because he doesn't want to strip the threads on the set screws. They only have to be snug in order to do their job. Once the first set screw is installed, he installs the second one. The parallel clamp is no longer needed, so he removes it. Next, the lower bearing shell is rotated back into position. Then the bearing is covered so the chain, hoist, and sling can be safely removed. Next, he's ready to install the top bearing shell. Of course, before doing this, he checks the match marks to make sure he's mating the shell halves properly. Then he sets the top shell in position. But he uses care while doing this. If the shell is dropped, serious damage could result. With the top journal bearing shell in place, he's ready to fasten the two shells together. The first step here is to reinstall the dowel pins. You'll recall that this bearing uses two dowel pins in opposite corners. The dowel pins are used to maintain correct alignment of the bearing shells. They have to be installed at this point so that proper alignment is established before the bolts that fasten the shells together are installed and tightened. Once both of the dowel pins have been set in position, he then taps them with a hammer in order to make sure that they're seated firmly. At this point, proper shell alignment has been established, so he's ready to reinstall the bolts that fasten the top shell to the bottom shell. These bolts are also installed on opposite corners of the bearing. As he threads the bolts into the shells, he feels for any resistance. The bolts have to be torqued, and resistance in the threads could result in unreliable torque readings. That could result in damage to the journal bearing or the thrust bearing. So he continues to thread the bolts in by hand until they're both seated. Then he performs a final tightening with a torque wrench. The bearing is fully reassembled at this point. The next step is to assemble the bearing housing. So the worker places new gaskets on the flange mating surfaces of the housing. These are gaskets he cut using the old ones as patterns. He places half of the gasket on one side of the flange mating surface. This particular housing uses a two-piece gasket. This type of gasket has to be used in order to allow the shaft of the pump to pass through the housing. He then presses down on the gasket to make sure that it's properly seated over the studs and that it lies flat on the flange mating surface. Then the other half of the gasket is put on the mating surface on the opposite side of the housing. Then a cover is placed over the open bearing housing. While the worker finishes covering the exposed bearing, why don't you discuss the work performed up to this point? When you come back, we'll see how the worker continues to assemble the bearing. Before the break, the worker covered the exposed bearing. Now he's ready to complete the bearing assembly. The next step is to position the upper bearing housing on the lower housing. Once the upper housing has been lifted over the bearing, it's connected to the chain hoist. While handling the chain hoist and upper housing, it's possible that grit or paint chips could fall into the lower housing and cause bearing failure. So a cover is a good thing to use. It could save a lot of unnecessary trouble. With the upper housing suspended from the hoist, the cover is taken out of the way. While doing this, he's very careful not to bump the suspended upper housing and keeps his hands out from under it. When the cover's been completely removed, he's ready to lower the upper housing into position on the lower housing. While doing this, the worker checks continuously to be sure that the upper housing doesn't bind on the studs. If it did, the threads could be damaged. So he operates the chain hoist while his helper guides the load. If binding did occur, they would raise the cover and check the threads for damage. In this case, there is no binding, so the worker continues lowering until the upper housing comes to rest on the flange gasket. The load off the chain hoist, it's disconnected, the chains are moved out of the way. Once the rigging equipment is out of the way, he's ready to install the nuts on their studs. So after taking off his gloves, the worker removes the nuts from the bag they were placed in when the bearing was disassembled. Then he threads the nuts on the studs. While installing the nuts, he again feels for any resistance in the threads. These nuts have to be torqued. And as we said earlier, if there's any resistance in the threads, it could result in an inaccurate torque reading. That could result in distortion of the flange mating surface, which in turn could result in leakage once the equipment was placed back in operation. So he continues threading the nuts on the studs until they're all hand tight. Then the nuts are torqued. While doing this, the worker applies the torque value specified in the manufacturer's instructions. He also uses a crisscross pattern. This is done, as always, to evenly apply force to the flange mating surfaces. This minimizes the possibility of the flanges being distorted as stress is applied. So he continues torquing the nuts until all of them have been tightened to the correct value. At this point, the worker is ready to make a final check of the end play of the pump's rotating element. He wants to be sure that the thrust bearing still has the correct oil clearance. So he positions the dial indicator. The procedures he uses here are the same ones he used the first time he checked the thrust. He places the magnetic base on the outer portion of the housing. Then he positions the dial indicator button on the end of the shaft. He has his helper move the shaft all the way in one direction. Then he zeroes the dial indicator and signals his helper to move the shaft all the way in the other direction. He checks the total travel of the thrust bearing. Then he has his helper move the shaft all the way back again to verify this reading, making sure that the indicator has returned to zero. With that, he's finished checking the thrust, so the dial indicator is taken off the bearing housing and set aside. Then he records the thrust reading and compares it with the manufacturer's specifications, as well as the reading he took before disassembly. In this case, the thrust travel is found to be acceptable. Then, since it's no longer needed, the lifting eye is removed from the bearing housing. The next step is to reinstall the worm gear on the shaft. So he places the key back in its keyway. Once he's sure the key is in the correct position, he slides the worm gear back on the shaft. While doing this, he checks to be sure the keyway in the gear is properly aligned with the key, and to be sure the gear doesn't bind on the shaft. He continues checking until the gear is properly positioned against its shoulder on the shaft. Then he reinstalls the set screw. Again, he uses a hex key wrench to do the final tightening of the set screw, but he's careful not to over-tighten. That might strip the threads. The only reassembly step remaining is to install the end cover, together with a new gasket on the bearing housing. Since this is a vertical surface and no studs are used, he needs something to hold the new gasket in place, so he applies a little light grease to the sealing surface. The purpose of this is not to act as a sealant, but to hold the new gasket in position until the cover is installed. So after applying the grease, he's ready to place the new gasket in position. As before, he's already cut a new two-piece gasket, using the old one as a pattern. So he presses one half of the gasket into position, taking care to line up the bolt holes as he positions it. Then he does the same thing with the other gasket half. He positions it on the sealing surface, carefully lining up the bolt holes and pressing the gasket into the grease so that it is held in place. With the gaskets in position, he signals his helper to give him a hand installing the end cover. Since there are no studs to hang it on, installing the cover takes a little help and coordination. After checking the sealing surface on the cover, he and his helper place it in position, taking care not to disturb the gasket and also positioning the cover so the bolt holes are lined up. Then, while his helper holds the cover in position, the worker installs the bolts. He threads all the bolts in hand tight and then tightens them with a wrench, as always using a crisscross pattern. With that, we've seen maintenance procedures for a typical tilting pad oil film thrust bearing. Both of the thrust bearings we've talked about so far are plain bearings, but anti-friction thrust bearings are also used. These can either be roller-type thrust bearings or ball-type thrust bearings. Maintenance procedures for anti-friction thrust bearings are essentially the same as for anti-friction journal bearings. We still need to talk about the lubrication of bearings. But before we get to that, review the reassembly of tilting pad oil film thrust bearings with your instructor. So far, we've talked about the disassembly, inspection, and reassembly of bearings. We pointed out that proper lubrication is crucial in maintaining a bearing, but we need to discuss it in more depth. There are probably many types of lubricants used in your facility. They are either greases or oils, and they're used on just about every piece of machinery you maintain. There are many types of lubrication systems. Some equipment, like this motor, may use pre-lubricated sealed bearings. Others may use a grease system that has to be serviced periodically. In addition to grease, many pieces of equipment use oil lubrication systems. All the bearings we've seen in this module use some sort of oil system. The plain journal bearing used an oil system with a slinger ring. The gear reducer used an oil bath system to lubricate the bearings in the gears. The tilting pad oil film thrust bearing used a force recirculation water-cooled lubrication system. There are also oil lubrication systems that periodically feed oil to critical points in machinery. As you can imagine, there are many different lubrication systems, but a few basic principles apply to all of them. The correct type of lubricant has to be used, and the lubrication system has to be kept clean. The best way to understand is to look at some typical examples. One of our workers is getting ready to grease one of our pump motor bearings. Let's see how it's done. Before beginning any lubrication, the worker first refers to the manufacturer's instructions to find the type of lubricant that is to be used and the amount of lubricant that should be used. Before beginning any work, he checks to be sure that the equipment has been tagged out and properly isolated so that he won't be accidentally injured while doing his work. This piece of equipment uses a grease lubrication system. First, he wipes the lubrication fitting and the area around it to keep dirt from being pumped into the bearing when it is greased. Next, he removes the plug from the relief opening. This type of lubrication system uses a relief opening, so that as grease is pumped into the system, it's allowed to come out the relief opening. After he's removed the plug, he's ready to pump grease into the bearing. With this type of system, grease is pumped in until it just starts to come out the relief opening. This indicates that the proper amount of lubricant has been put in the bearing. Once he's finished pumping grease into the bearing, the next step is to remove any excess from the outside. So he wipes off the lubrication fitting and then removes the grease from the area around the relief opening. With that done, the next step is to reinstall the plug and then tighten it with a wrench. As he does this, he's careful not to over-tighten. He doesn't want to strip any threads. After the plug is completely tightened, the worker makes one final check and wipes away any remaining grease residue. This is done to make sure that grit doesn't get mixed up with the grease and accidentally get pumped into the lubrication system. That's one typical example of a grease lubricated bearing. There are other bearings that don't use relief holes. Some of these are seal bearings which should never be lubricated. In other cases, you're required to pump a given amount of lubricant into the bearing at specific intervals. You'll have to rely on the manufacturer's instructions to tell you the amount of lubricant that should be used. In addition to maintaining grease lubrication systems, you're also going to be involved in maintaining oil lubricated systems. As we said, there are many types. One of the main concerns in any lubrication system is making sure the equipment has the right amount of oil in it. Sometimes sight glasses are used to monitor the oil level. In other cases, the oil is checked by removing a plug to check the oil level. There are also systems that are designed to maintain a constant level of lubricant. They have a reservoir which supplies oil to the bearing as needed. They may look like a sight glass, but they're not. They don't show how much oil is in the bearing. They show how much oil is still in the reservoir. There are times when oil has to be changed. Sometimes this is done seasonally, or it's done because the equipment operates in an area where contamination is likely. One of our pumps is located in an area where oil can get contaminated. We change oil on a regular schedule and take oil samples. This way we prevent contamination and we monitor the condition of the oil. A worker is getting ready to change oil in a bearing equipped with a constant level oiler. Let's see how it's done. Before starting, the worker has checked to be sure the pump is properly isolated and tagged out. He refers to facility procedures to double check that he selected the correct type of oil. He also wants to be sure he knows how much to use when he refills the lubrication system. Before draining any oil from the system, he first cleans the outside of the bearing housing. This is to remove any grit or dirt from the housing. If the grit got into the system, it could cause contamination and damage the bearing. So he uses a brush and rag to clean away any heavy buildup of grit. Once the cleaning is complete, the worker removes the oil reservoir from the constant level oiling system. Then the oil is drained from the reservoir bottle. Once the reservoir bottle has been drained, the next step is to drain the oil from the bearing housing. So he unscrews the drain plug from the bearing housing. Notice that he has the bucket in position in advance so that oil won't be spilled when the plug is removed. Once the plug is out of the housing, the oil starts draining from the drain hole. At this point, the worker uses a clean jar to collect a small sample of the oil. It will be sent away for a laboratory analysis. Once he's collected the oil sample, the remaining oil is allowed to drain from the bearing. Once all the oil is drained out, he replaces the drain plug and tightens it with a wrench. As always, he uses care not to cross the threads and not to over-tighten the plug. With the drain plug installed and tightened, he's ready to refill the bearing housing. So he removes the filler plug, which in this case doubles as a vent fitting for the housing. Then he sets a funnel in position to allow pouring the oil into the housing. In this case, he pours oil into the housing until it runs out the inverted fitting for the constant level oil supply reservoir. This tells him that a normal level has been established. In other bearing designs, a sight glass or some other level indicator is provided. While the excess oil drains out, he reinstalls the vent fitting. Once this has been done, all he has left to do is to refill the reservoir for the constant level oiling system. So he pours oil into the reservoir and then reinstalls it on the bearing housing. That ends our discussion of bearings. While we've seen a number of examples, this program is general in nature. If you need specific information on bearings in your facility, talk to your instructor now or discuss it with your supervisor on the job.